Okay, so today we're going to start with an introduction to shapes. As you know, we've been working on working our way through the elements of art, and we've covered color, value, and texture. We only have line and shape left as our sort of as we work our way through studying lots of different techniques and artists and things within that, but using the elements of art as our starting point for each of our sort of weeks going in and diving into those elements. So we're starting shape today, which is a pretty basic sort of concept that I've been dealing with since you were tiny tots, okay? Which is not a bad thing. It gives us a good basis to build upon. I was disappointed to know that, or to find that my favorite didn't have a video for shape, but I did find another good one. This one's more art. Well, it's a different kind, a little bit, but it's really good. So we're going to start by watching that. Let me get that started here for you.
Fruit has played a prominent role in the history of art. It's long been a favorite subject for artists, making still life paintings and drawings. Looking at still lifes of fruit is a useful way of studying how artists approach making shapes. Shape is one of the 7 elements of art, along with line, form, texture, value, space, and color. When the beginning of a line connects with its own end or intersects with another, a shape is formed. In visual art, shapes are flat and are defined by their length and width. In other words, they're two-dimensional. There is an infinite number of shapes, but all fall into one of 2 categories: geometric or organic. Geometric shapes are commonly recognized such as squares, hexagons, rectangles, and circles. Organic shapes are free-form and often one of a kind. Artists learn how to see the world around them as basic shapes. Simplifying objects into geometric and organic shapes makes drawing them easier. Shapes inherit the qualities of the lines that were used to construct them. For instance, this painting by Cezanne has heavy, solid outlines that define the shapes, whereas the fruit in this ink drawing by Manola Rocchi is made up of very soft, fuzzy lines. Each approach to making lines produces different feelings and associations in the viewers. Some artists make oranges that are perfectly round, while others draw or paint every little bump and detail of the skin. The next time you're looking at a painting or drawing, try to notice how the artist is using shape in their work. If you were making a drawing or painting, how would you interpret the objects in front of you? Would you draw them as faithfully as possible? Or would you choose to represent them more abstractly? Practice for yourself by setting up a bowl of fruit and drawing what you see.
Okay, so a couple things from that video. First of all, I really liked that there was a couple lines. I like the line where she was like, um, the um, shape takes on the quality of the line that defines it, or something like that. I thought that was a very poetic and good description. Um, I thought it was just an interesting way to describe it. A lot of times we define shape as an enclosed space, line enclosing space, So I thought that was a much better way to describe it. It takes on the quality of the line that encloses it. That's a good way to say that. So I like that. Another thing in there where she's talking about the different, well, first of all, that they use fruit, one of the oldest subjects and kind of universal subjects that artists portray in a still life. There was a couple artworks in there by people you should have recognized. There was an Andy Warhol, there was a Lichtenstein, there was actually, now that I think about it, there was not a Van Gogh, there was a Picasso. So you see too. So I did like that as well. Okay, so just a small introduction shape there, which I liked. And let's go through some other parts of that now as well. So over here on the left-hand side of the screen, you can zoom in. I can't really do that within my PowerPoint here, but you can see there is a row of brightly colored shapes. And you, I bet, because you guys are super smart, could name every single one of those. Okay, those are geometric shapes. Any shapes that you can name are geometric shapes. Any shapes that are free form or unnamed in like math class kind of terms are organic shapes. Okay, so let's get into that right now. Kind of shapes that we would be dealing with, and also symmetry, which is a concept that you're probably also familiar with, but we're going to talk about it in terms of the art room. Okay, so all shapes fall into two categories, period. It's that plain and simple. Shapes are two-dimensional, which means only two dimensions that we measure, length and width, no depth. That's sometimes people throw around terms kind of willy-nilly, like, oh, shape, form, and they kind of space, and they use them interchangeably, but that's not accurate. A shape is only length and width, no form or space or depth to it. And they fall into literally just two categories. Even though it feels limitless in the amount of shapes we have, they're either geometric, which is named, and sometimes people call them regular. So those are like the mathy ones, right? Circle, hexagon, parallelogram, you name it. Those are the geometric ones. Anyone that you cannot give a name to is organic or freeform. And yeah, you could look at the ones on the screen right now and be like, tree, but it's not really, that's not a geometric name, okay? Freeform or organic is the artistic word, is the alternative, because you can't go to math class and be like, where's the shape tree? Okay, that doesn't happen. And we don't use stuff like blob, okay? We say organic. So there's basically just the two types. Those are your options, but then almost limitless possibilities within those, okay? So as an artist, you're going to be trying to train yourself to see the three-dimensional world around you in these simple 2D shapes so that you can not only depict that more accurately, but more convincingly as three-dimensional things on a 2D surface, okay? So take this example of the chair. The chair is a three-dimensional object, and you're viewing it and you're going to try to depict it two-dimensionally, but then create that illusion of space. See, it's kind of like this play back and forth. Shapes that are objects, okay, such as the chair itself, are defined as positive space or positive shape. And then the stuff around that, that's the negative space or the negative shape. So when you look at the picture of the chair just defined as like black, not as black and white, not as chair. Okay, so the black part is a positive and the space around it, the white part, is the negative. So something we're going to do next week is expand on that and just isolate things that way, because that's a really good way to train yourself into understanding a subject and also drawing it. Okay, that's a really good way to develop your skills as an artist. So this relationship between positive and negative shapes is really important to help our brain understand what we're seeing, whether you're drawing as an artist or not. So like if you look at these three examples here in the middle, the one on the left, very complex, pretty complex image of a bicycle, can be reduced into the, this one's actually opposite of the last slide, what it was written there. The positive is white and the negative is black. That one in the middle, you can't define it that way, and the one on the right, because they're both positive and negative. The one on the right, I did not realize initially is one of those double images. Can anybody see the double image going on there? It's got two separate images. Anybody see both of them? You can speak up, shout out, give a thumbs up. Zach, you want to speak out and tell us which two they are? Because some people will not see both of them until it's been like brought to their attention.
A bear and an eagle.
Oh, yes, in the middle, absolutely. And isn't that fascinating, the way that they were able to use the negative space around the bear's head to fit the eagle right in it? I love it. What about on the far right, up in the corner? Anybody see the double image there? That one's harder.
It's like a face and then a guy playing saxophone.
It is. So when I was getting this slideshow together, I was searching for the relationship between the positive and the negative. That concept is called figure ground. And so I was searching for images and I found the picture of the woman. It was a thumbnail size, right, on my MacBook at home. And I put it into the slideshow, which was like maybe this big. And then today, this morning, first period was the first time I looked at this on my Mac, which is gigantic right in front of my face. And I pulled it up and I put it up, I'm like, oh my gosh, there's a guy playing saxophone there. Didn't see it until it was large. And, you know, I was like looking at it from a whole different perspective. And then I realized that it was a double image that using the positive and negative space carefully arranged, just like the bear and the eagle. And then I was like, oh man, look at that. Because that's one of those illusions that you can create by playing with that figure ground. The one below that with the hand is not figure ground, but I wanted to throw it on this slide anyway. Sometimes there's like kind of two approaches to drawing, two basic approaches to drawing. If someone said to you, draw a picture of a hand, you know, for an assignment, one way that people draw is they would maybe like look at their hand here. I'll just do a demo in midair here. They would look at their hand and with their eyes, you trace, like with your vision, you know, you're tracing along the outside edge, tracing along with your eyes. And then your hand holding your tool is doing the same thing. And you're drawing what you see on the paper while your eyes trace along the edge. That's called contour line drawing, okay? So you would be, the product on your paper would be to draw the line that your eyes are seeing, okay? So you're drawing like the outside edge with a line. That's called contour line drawing. The other way is to start with the basic shapes, like you see here in this diagram. So instead, you're looking at your hand and you're like, oh yes, this is basically a big rectangle-ish shape. And to get this part right, I would draw a simple triangle. And I might draw a triangle here too, in the negative space to define the angles and stuff between my thumb and my finger. And then I might draw, you know, rectangles for this part of the knuckle and going back in later and adding more sophisticated detail and shape and whatever. But you could see how that artist is showing how they start with simple sort of robot looking blocky shapes and digits, but then use those to make an accurate hand, which is a much more complex shape. So those are different methods of drawing. Some people might prefer one over the other, but they're not necessarily better. They're just different. Okay, so that's the way that we would use simple shapes to start a complex drawing of a complex shape. Okay, so now let's move from just talking about shape to talking about symmetry. Symmetry should be not a brand new concept to anybody, but let's, you know, kind of apply it to what we're talking about here with the introduction of shape. Symmetry is a type of formal balance. Okay, formal means kind of intentional and organized, in which an image or object maintains equitable weight when divided by a line of symmetry. So this means it doesn't say there has to be exactly equal. Sometimes it might be, you know, like I think I remember showing you with my notan. Notans are an example of where things are symmetrical, but sometimes maybe it's not exactly the same on this side as this side. Things might be shifted a little, or you know, slightly different. Like on this side, maybe it's a letter A, and on this side it's a letter B, for example, but they're roughly the same. So if you draw a line down the center of this butterfly, the right side, I didn't mean to do that, hold on. That's what I was trying to do. The right side and the left side look about the same. They are a reflection of one another, and that's called linear symmetry. It's also sometimes called bilateral symmetry because it only has one line of symmetry. You can divide it in half vertically, but you can't divide it in half horizontally. And by the way, it's really mean to fold butterflies, so don't do that. Okay, no folding of butterflies. Here's some more examples of linear or bilateral symmetry. Okay, and then an alternative, because there are more than just two types of symmetry. Radial symmetry is a type of formal balance in which objects radiate around a center point and has more than one line of symmetry. Okay, so basically, this can get really exciting and complicated because when you start from a center point, you basically have, well, you don't have infinite, but you could divide that circle in using lines as many times as you could, and you would still have symmetry as long as you add equal parts as you go. So the best way to create an image with radial symmetry is to work from the center outwards. If you make sure that you repeat the same elements all the way around from the center, then it will be symmetrical. So these can be man-made, but they're also found in nature, like I was just showing you. There are lots of examples in nature. So here's the math part. And like I've done a lot of mandalas and I rarely measure. I just can't be bothered with measuring. So you can use a template, you can measure, but the trick is you just have to always keep adding the same every time. You have to make sure, if you want it to be symmetrical, that you're dividing the same and keeping it equal. Okay? Anybody have any questions so far on symmetry, shapes, any of that stuff? Okay, in my Twitter feed, I wanted to show you, I just coincidentally, like last week, this came up in my feed. This man created something that would allow him with his camera to take what he claims are the highest resolution pictures ever of snowflakes. I think this looks amazing. And look at what he's, you know, this article is great. It's like the challenges of photographing snowflakes are obvious, fragile and tiny, just a few millimeters across. It can melt in seconds. So he's, you know, this article goes on to talk about how amazing they are, you know, as subjects, and then the things that this man did to capture them, which includes creating modifications to his camera and all kinds of things, and the speeds that he shot at, which were amazing. And I wanted to show them to you because not only are they a great example of radial symmetry, but they are simply amazing. Simply amazing. So I think this is the first one. Yep, this is the first snowflake ever caught on film. And that was back in 1885, I think. A long time ago. These are better, but that's still pretty impressive, actually. Okay, All right. So let's see, how are we doing on time? Okay. This right here is a little thing I have. This is about a little more about the science of symmetry.
When you hear the word symmetry, maybe you picture a simple geometric shape like a square or a triangle,
I like the
or
animation
the complex
on this a
pattern
lot.
on a butterfly's wings. If you're artistically inclined, you might think of the subtle modulations of a Mozart concerto or the effortless poise of a prima ballerina. When used in everyday life, the word symmetry represents vague notions of beauty, harmony, and balance. In math and science, symmetry has a different and very specific meaning. In this technical sense, a symmetry is the property of an object. Pretty much any type of object can have symmetry, from tangible things like butterflies to abstract entities like geometric shapes. So, what does it mean for an object to be symmetric? Here's the definition. A symmetry is a transformation that leaves that object unchanged. Okay, that sounds a bit abstract, so let's unpack it. It will help to look at a particular example, like this equilateral triangle. If we rotate our triangle through 120 degrees around an axis through its center, we end up with a triangle that's identical to the original. In this case, the object is the triangle, and the transformation that leaves the object unchanged is rotation through 120 degrees. So we can say an equilateral triangle is symmetric with respect to rotations of 120 degrees around its center. If we rotated the triangle by, say, 90 degrees instead, the rotated triangle would look different to the original. In other words, an equilateral triangle is not symmetric with respect to rotations of 90 degrees around its center. But why do mathematicians and scientists care about symmetries? Turns out they're essential in many fields of math and science. Let's take a close look at one example, symmetry in biology. You might have noticed that there's a very familiar kind of symmetry we haven't mentioned yet, the symmetry of the left and right sides of the human body. The transformation that gives this symmetry is reflection by an imaginary mirror that slices vertically through the body. Biologists call this bilateral symmetry. As with all symmetries found in living things, it's only approximate, but still a striking feature of the human body. We humans aren't the only bilaterally symmetric organisms. Many other animals, foxes, sharks, beetles, that butterfly we mentioned earlier, have this kind of symmetry, as do some plants like orchid flowers. Other organisms have different symmetries, ones that only become apparent when you rotate the organism around its center point. It's a lot like the rotational symmetry of the triangle we watched earlier, but when it occurs in animals, this kind of symmetry is known as radial symmetry. For instance, some sea urchins and starfish have pentaradial or fivefold symmetry. That is, symmetry with respect to rotations of 72 degrees around their center. This symmetry also appears in plants, as you can see for yourself by slicing through an apple horizontally. Some jellyfish are symmetric with respect to rotations of 90 degrees, while sea anemones are symmetric when you rotate them at any angle. Some corals, on the other hand, have no symmetry at all. They are completely asymmetric. But why do organisms exhibit these different symmetries? Does body symmetry tell us anything about an animal's lifestyle? Let's look at one particular group, bilaterally symmetric animals. In this camp, we have foxes, beetles, sharks, butterflies, and of course, humans. The thing that unites bilaterally symmetric animals is that their bodies are designed around movement. If you want to pick one direction and move that way, it helps to have a front end where you can group your sensory organs, your eyes, ears, and nose. It helps to have your mouth there too, since you're more likely to run into food or enemies from this end. You're probably familiar with the name for a group of organs plus a mouth, mounted on the front of an animal's body. It's called a head. Having a head leads naturally to the development of bilateral symmetry. And it also helps you build streamlined fins if you're a fish, aerodynamic wings if you're a bird, or well-coordinated legs for running if you're a fox. But what does this all have to do with evolution? Turns out biologists can use these various body symmetries to figure out which animals are related to which. For instance, we saw that starfish and sea urchins have fivefold symmetry. But really, what we should have said was adult starfish and sea urchins. In their larval stage, they're bilateral, just like us humans. For biologists, this is strong evidence that we're more closely related to starfish than we are to, say, corals, or other animals that don't exhibit bilateral symmetry at any stage in their development. One of the most fascinating and important problems in biology is reconstructing the tree of life, discovering when and how the different branches diverged. Thinking about something as simple as body symmetry can help us dig far into our evolutionary past and understand where we, as a species, have come from.
Okay, so at the end there, getting a little bit, into biology, which departs slightly from the art, except that I did find that I could make a connection between the part where he kind of cheekily talks about arranging the features in the head of bilateral symmetry, and I was thinking about how when an artist creates a composition that is bilateral symmetry, that is more likely to have a focal point that is located out of the center, and when you have radial symmetry, the focal point is most likely in the center. So I thought that does kind of parallel or mirror the idea that like starfish or sea urchin or whatever those things are, like the locus of the most important things like mouth, brain, eyes, whatever those things have, would be in the center, whereas, a shark, a human, a fox, all those other things have a head, and that's located, near the front. So I did find a parallel there, but it was kind of a stretch. I did think that the rest of the animation and stuff was pretty cute and worth looking at. Okay, so today it was important for us to look at the sort of the intro here to shape and why we care about it. Two-dimensional makes up simple, more complex shapes. Two basic categories being geometric and organic. We are going to be looking at mandalas starting tomorrow. Some of you have drawn mandalas in the past. You're going to have 3 options for your big work this week, and only one of them would be drawing. So I have lots of good ideas for that. So let's go to the calendar here. Our calendar has been through many changes this week since it just kept getting rearranged because of the snow day, but that's no biggie. So tomorrow, I'm going to talk some more about mandalas and go over the classwork for the week, which won't be due until Friday now because everything got changed around so much. Does anybody have any questions before I go into Schoology and show you something that I need to show you there?